And let's solve the today's LeetCode challenge, which is restore the array from adjacent pair. So here in this problem, we have to form an array from the adjacent pairs which are given to us. Let's try to understand this problem further. So here, let's say we are given all the pairs, adjacent pair from an array. So if we try to form the array back from these pairs, let's say 2 and 1. In the original array, 2 and 1 are connected. 3 and 4. 3 and 4 are adjacent in the original array. Also 3 and 2 are adjacent in the original array. So we can make a connection here instead of writing separately. So here this 1, 2, 3, 4 is our array. So in the first approach, the first approach came in my mind is whether there is any way to insert all these pair in a fixed size array, but I don't think that would be feasible. Let's say if we have an array and we try to fill it using first pair 2 1, and for the second pair we don't know where exactly do we have to put it in the resultant array. So it means that the fixed size array is not going to work for us. Other solution is like mapping, tracking these pairs in the form of a map. Let's say 2 1 3 4 3 2. If we try to insert it in a map, from the map using the map we can try to form our array. Let's say 2 is connected to 1, 3 is connected to 4, 3 is connected to 2. If we start with an element, let's say start with 2. In this way 2 is connected to two element 1 and 3. So at one place we can put 1, other place we can put 3. Now what we will check is we will check for 1 and 3 whether they are connected to anyone else or not. The 1 is connected to 2 only, so that's the only adjacent element. So 1 is, I think, either the starting or at the end of this array. So 3 is connected to 4 further, so 3 is connected to 4. So but in this case we are seeing some kind of complexity, we are filling in the board direction, something like that. So instead we can form the adjacency list of these pairs, adjacent pairs. If you try to think it in terms of a graph, so you will get to know that these we can consider as the edges of a graph. Let's say these are the nodes, and the edges we connected, we got our actual array. So if we try to form the adjacency list of this given input, so we will get to know, we will get the adjacency of integer and the list of all the neighbors of this node. Now let's try to fill the adjacency list using these pairs. So 2 is connected to 1. In our array, the node 2 is connected to 1. It means 1 is also connected to 2 in the adjacency, as per the adjacency list. So 1 is connected to 2 and 2 is connected to 1. And for the next pair, 3 is connected to 4 and 4 is connected to 3. And further 3 2. So 2 is connected to 3 and 3 is connected to 2 also. So if you analyze this list, we can see that all of these items are connected to either one neighbor or two neighbor. So if an array element is connected to one neighbor, it means that is the extreme end of the array. So 1 and 4 will be our extreme end because they are only having one neighbors. The middle elements are going to have left and right neighbor, but these are going to have one neighbors. So 1 and 4 are neighbors. So we can start with any pair. Let's say 1 or 2. If we are starting with 1 or 2, because 1 is only having one neighbor and 2 can have other neighbors, that we will insert after 2. So we can start our array from this. So 1 is having neighbor 2. So for 2 we will check how many neighbors that it has. So 2 is having 1 and 3. So 1 is already visited or maybe considered. So we will use 3 in the next place. 3 is connected to 4 and 2. 2 is already there, so we will use 4 as a next element. So 4 is connected to 3. So 3 is already visited, so we are not going to insert any element. So the 1, 2, 3, 4. This is our array from this adjacency list. So what we did is, firstly, firstly at the first stop, we prepared the adjacency list using the given pairs, and after that we need to analyze which is going to be our starting point. Starting point can have one neighbor, and then after we got the starting point, we can just do the iteration traversal of this graph. Either you can do the BFS or DFS. So I'm going to do the DFS here. So from 1 to 2, so 2 to further, and then 3 to further. Okay, let's try to write the code for this problem. So here we have a couple of steps to perform. Firstly, we have to form the adjacency, then starting point, and then DFS. After that, we will just return our result array. Okay, so how do we use the adjacency list of a graph? It is a map of a node and its neighbors. Node can be taken as integer, and its neighbors can be taken as list of integer. Like the 1 is connected to 2 and 2 is connected to 3, 4, like this. So let's call it adjacency new hash map. Now we have to fill this adjacency list. We will fill all the pairs for integer array pair adjacent pairs. Okay, so it can be possible that node is going to be inserted for the first time. If that is going to be inserted for the first time, we will just fill it with the empty list. Adjacent dot put if absent. We will check whether the pair 0 is having its value in the map or not. If it is absent, we are going to insert the empty neighbor list, array list, that it does not have any neighbor currently, like for the second node, pair 1 and pair 0. Now what we'll do is adjacency dot get pair 0. From the pair 0, we will form a link with pair 1 and vice versa. Pair 0 is connected to 1, pair 1 is connected to 2. So now we have prepared our adjacency list. So now we have to find our starting point. Let's say our starting point is -1 in the starting. So we will iterate for all the keys in the map. Int key for adjacency dot key set. For all the keys, we are going to check if adjacency dot get key having size equal to 1. That is, if the key is having only one neighbor, so that key is going to be our starting point, and we will just break this loop. Its work is done. So now we will do the main part, which is doing a DFS integer array. Firstly, we'll have to get the integer array. This is our resultant array. If the given array is 1, 2, 3, 4, array having 4 size, in this case we are going to have n minus 1 pairs, 1, 2, 2, 3, 3, 4. So the pair size plus 1 is going to be the size of our array. New integer adjacent pairs dot length. So this is my resultant array. So in this way we are going to start it from this start variable. So here from this adjacency our start was is equal to 1. So our resultant 0 is going to be 1, sorry, start, and resultant 1 will be the neighbor of the start because that is our first pair. So how do we find that neighbor of the start? Adjacency list dot get start and get 0. So what we are doing here, we are trying to fill our array, and from the adjacency list it is clear that 1 is at the extreme end and the 1 is having only one neighbor, so we can also put it in the resultant array. And now from third index to the last we will keep on filling our array by doing the DFS over this adjacency list. Okay, so we have the first two elements, and now int I equal to 2 while I is less than resultant dot length. For all the elements what we are going to do is we will check for its neighbors and we will insert the non-visited or maybe non-previously used neighbor at the next position. Okay, so while I less than resultant dot length we will get the neighbors. Adjacency dot get. So whose neighbor do we have to get is resultant of 1, and I value will be iterate over the resultant array, and we have to get the neighbors of I minus 1th location, which is resultant of I minus 1. We are at this index and we have to find neighbors of this, so resultant of I minus 1 will be the value. Okay, so we have the list of neighbors, and for each neighbor if the neighbor is not equal to resultant I minus 2, we found out the neighbor of 2. 2 is having two neighbors. 1, we will check that with I minus 2 value, which is the previous value of 2. If that is equal to 2, we will skip that neighbor, and the other neighbor we will insert it in the resultant array. So if that neighbor is not equal to resultant I minus 2, in that case resultant I is going to be equal to that neighbor. And after checking all the neighbors of a node, we will do the I plus plus. We will iterate the value. So after checking all the neighbors of 2, we will increment the value of I. I was initially pointing to 0, 1, 2, 2. So after filling the value of neighbor in second index, we will move to third index. So here we have to increment the I plus plus. Earlier I did the I plus plus in this loop, but later on found out that it is wrong. Okay, so now we can the resultant array to run the problem. Okay, we got runtime error. Array index out of bound. Array index out of bound. This resultant one does not exist. Okay, so this resultant array is not equal to adjacency pair dot length. It would be plus 1 because all the elements, let's say for 1, 2, 3, 4, we are going to have three set of pairs 1, 2, 3, 2 and 4, 3. So we are given pairs So our resultant array would be length of pairs, so sorry, the number of pairs plus 1. Let's submit it again. The sample test case passed. Trying to submit it. It worked. Okay, thank you guys.